One last concept I'd like to discuss regarding indices is for using them for sorting. So far we've been talking about using basically a hash table to create an index. But one of the characteristics of a hash table is that it's not sorted. A hash table is just a mapping of keys to values. And if you remember how they're implemented as a big array with all these fields, and inside these fields are these keys that are basically the hashed version of some value. If you add a new element into your hash table, the new element can go into any one of these cells. It could be the case that this key was added last. It just happens that key hashed to this position 0 in the hash table. So we lose our sorting information when we use a hash table. And we saw some SQL queries before that use the order by statement. Obviously that requires some sort of sorting. So there's a different type of mapping we can use, and this is called a tree. Trees are a basic data structure that accomplish something similar to a hash table, but they have the nice property that they are sorted. Why would you ever use a hash table when you can use a tree instead? Well, the downside is that the lookups are slower. Hash tables lookups are faster. So I don't think you've talked about these algorithms yet in 101, but basically a hash table has constant time lookup, which means that generally looking up any particular key in our hash table is not a function of the number of keys in the hash table. Their inserting can be a little hazardous. Remember, if there's collisions, I think you talked about that in 101. But in general, the lookups are going to be constant time. And in a tree, the lookups are going to be roughly a function of log n, where n is the number of elements in a tree. So lookup speed decreases with the size of the tree. And depending on what you're going to use your index for, you may choose to use a hash table or a tree. Many databases let you choose. Some actually don't, or some choose for you. The interesting property of indices used by most relational databases is that they preserve sorting, and there's some cool things we can do with that. One is that if you want to find if you wanted to find all of the links in your database sorted by votes, if you created an index on votes, that'd be a very, very fast query. You would just go to the front of your tree, your index on votes, and just read off the links. And I'd like to show you how we use that at Reddit to make the hot algorithm work.